The efficient allocation of scarce resources is probably one of the most fundamental questions in economics. In this project, I study a very stylized model of allocation. There's a principal who can allocate a good to an agent, and I denote this allocation decision by x. So x is the probability of allocating the good to the agent. Both players hold private information. The agent privately learns his valuation of the good, and the principal also privately learns the cost of allocating the good to the agent. I assume that the preferences are such that there's a conflict of interest, namely the principal wants to allocate efficiently. She wants to allocate the good to the agent whenever his valuation exceeds her cost, whereas the agent does not internalize the cost, has always strictly positive valuation, and therefore just wants to maximize the probability of receiving the good. In this situation, I ask what is the best mechanism for the principal to design and to commit to elicit the information from the agent about his valuation, and then to use this information to allocate as efficiently as possible. If you would allow the principal to use monetary transfers in this mechanism, this would be a rather easy exercise, because then the principal could commit to the following mechanism. She could just offer the good for a price, which she always sets to equal the cost she observes. In this case, the agent would of course buy whenever his valuation exceeds the price, which is equal to the cost. So in this mechanism, we would implement the first best efficient solution. The problem is that there are many environments where we cannot use monetary transfers as designers. So the literature on mechanism design without monetary transfers has discussed many such instances. You can think of allocation of essential goods like kidneys, social welfare benefits, intragovernmental allocations of resources and tasks. Also, an interesting example is the allocation of money. If you think about allocating money as the good, if the good you allocate is money itself, then you're back in the world of mechanism design without transfers, because you have only one instrument. For these situations, I investigate a new channel that the principal can use when she designs her optimal mechanism. And this channel is based on the observation that often in these situations, the information of the players, this is the value and the cost, are correlated. So how is this helpful? Suppose that value and cost are correlated. This means that agents with different valuations have different beliefs about the cost. And the optimal mechanism that I'm going to show you is exactly exploiting this difference in beliefs of agents of different valuations to screen them apart. This is also the main technical challenge in this project, to deal with this heterogeneous beliefs. Let's start with a preview. Suppose there are only two valuations, low and high, both are equally likely, and suppose that the costs are distributed continuously on an interval between the low valuation and infinity. More precisely, suppose that given that the valuation of the agent is low, the cost is distributed as the sum of the low valuation plus something exponentially distributed with mean 1. Yeah? In the other case, given that the valuation of the agent is high, suppose that the cost is distributed again as the sum of the low valuation, but this time plus something that is exponentially distributed with mean 5. So this is an example of positive correlation, because when the agent's valuation is low, then the agent expects the cost realizations also to be low. In his belief, he puts a lot of probability mass on low cost realization. Contrast, when his valuation is high, he puts more probability mass on higher cost realizations. So the problem here is, of course, that allocating to the low value agent is always inefficient, because the cost almost surely exceeds the low value. And if you want to allocate now to the high probability agent with some probability, then the problem is that you need to prevent the low value agent from mimicking the high value agent. In the optimal mechanism I'm going to show you in the next slide, the principal commits to allocate contingent on her cost realization and the agent's report. Yeah? And the mechanism will be such that the agent is incentivized to report his type, his valuation, truthfully to the mechanism. Okay, how does the optimal mechanism look? It is quite easy. It's here. So the principal tells the agent, you have two options. You can either report that you have low valuation, or you report that you have high valuation. If you report that you have low valuation, I will do the following. I have a cutoff here, and whenever the cost realization that I privately observe is below the cutoff, I allocate the good to you. If the cost realization is above the cutoff, I'm not allocating the good to you. But if you report that you have the high valuation, this is here, then I will do something different. Then I will have an interval, and only when the cost realization falls inside this interval, I'm going to allocate the good to you. If the cost realization is outside, so either too high or too low, I'm not going to allocate the good to you. Yeah? This is the optimal mechanism. First note that this is not ex post efficient, because in this situation, when the value is high and the cost is low, this is the situation where allocating is most efficient. The principal commits not to allocate. So how can this be optimal? The answer is it helps to screen the agents. So think about the agent. He understands this mechanism, and now he learns his true valuation. And we need the mechanism the mechanism needs to incentivize the agent to give his information truthfully. So the biggest problem here is that we need the low value agent. We need to prevent the low value agent from lying, from mimicking the high value agent. But if you go back to this mechanism, then for the low value agent to misreport his type is not quite attractive here. Why is that? Well, because the low value agent puts a lot of probability mass on his low cost realizations. But this is exactly where the principal commits not to allocate when the low value agent misreports his type as high. So for him, it is not very attractive to lie. So he's happy to tell the truth. On the other hand, the high value agent puts more probability mass on this higher cost realization, and therefore he thinks that betting on the cost realization to be in this interval, it gives him the good with higher probability. So therefore the high value agent is also happy to report his type truthfully. So what you can see in the structure of the mechanism is that this structure allows you to allocate the good with high probability to the high value agent and not create incentives for the low value agent to mimic the high value agent. Okay, let's recap the setting really quick. So the only thing I want to say here is that as we assume that the value of the agent is always strictly positive, and therefore, because we have only one instrument, the actual intensity of the valuation of the agent does not play a role, so it can be normalized to 1. Yeah? We could also write down the model with this utility function for the agent, where he only cares about maximizing the probability of receiving the good, independent of his valuation. For now, suppose that value and cost have finite support. Later I have an extension where I allow the cost to be infinitely discrete or an interval to cover the example I gave you before. Denote the joint probability of the valuation and the cost by f, and suppose that it has full support. Yeah. So now in terms of correlation, I distinguish 3 cases, and I have a very strong notion of correlation. In fact, it is the definition of affiliation. So I say the first case is positive correlation. This is a positive affiliation. This means that this ratio, where we divide the probability for a low value by the probability for a high value at the same cost, is strictly decreasing in C. Yeah. Then the other, the second case we investigate is independent. This is when these ratios are always constant in C. And finally, negative correlation. This is when this ratio is strictly increasing in C. Yeah. In the setting, the revelation principle applies. So this allows us to focus on truthful direct mechanisms without loss of generality. A truthful direct mechanism specifies for any possible valuation report V and any possible cost realization C an allocation probability X. Yeah? So the timing of such a mechanism is as follows. The principal announces it and commits to it. Yeah? Then the valuation and the cost realize. The agent observes his valuation and updates his beliefs about the cost realization. and then can report some valuation to the mechanism. Finally, the principal allocates according to this reported valuation and the cost realization she observed. Yeah? And such a mechanism is truthful if it incentivizes the agent to report his type truthfully. This is of course the case. This is captured in this equation, and this is of course the case when the agent thinks that reporting his type truthfully yields him the highest probability of receiving the good. So this is an example of such a direct mechanism. Here on this axis we have the cost. It's all finite. Here we have the valuations. There are only 2 in this example, and this is the allocation probability. Yeah? And then it will be for the agent, basically by choosing one of these 2 reports, he basically chooses between these 2 allocation lotteries, and we will denote these allocation lotteries as allocation schedules, correlated corresponding to the type. So this is the allocation schedule when he reports the low type. This is the allocation schedule when he reports the high type. So let's go to the results. First of all, we call a mechanism that ignores the message from the agent, the valuation report, ignorant. This is an ignorant mechanism. So this means that in an ignorant mechanism bases the decision on allocating the good only on the cost realization, not on the information of the agent. And it turns out that in fact, in 2 of the 3 cases, namely with independence and negative correlation, an ignorant mechanism is the optimal mechanism. This means that the principle does not elicit any information from the agent. In these 2 cases, the ignorant mechanism is also extremely intuitive. It is just a cutoff rule. The cutoff is given by this formula, and the mechanism proceeds as follows. The principle does not listen to what the agent reports to him. She just focuses on her own cost. If her own cost is below the cutoff, she allocates the good to the agent. Otherwise, she does not. Yeah? More interesting is the case of positive correlation. Here we will see that the optimal mechanism will have 2 properties. The allocation schedule, again these 2 are the lotteries, will be in single plateau form, and these single plateaus will be ordered in a specific way. Yeah. So what do I mean? When is an allocation schedule? So this is the lottery after a particular report. When does this allocation schedule have a single plateau? This is very easy. An allocation schedule always has a single plateau when if you take 2 cost realizations, C prime and a bigger cost realization C triple prime, and you have and it is the case that after C prime and after C triple prime the mechanism allocates with positive probability, then it is also already the case that for any cost realization in between these 2 cost realizations, the mechanism allocates with probability 1. So it maxes the probability of allocation out. So here's an example. The allocation schedule after the report high is not in single plateau form. Why is that? After C2 there's strictly positive allocation probability. After C4 there's also strictly positive allocation probability, but after C3 there's not. After C3 the allocation probability is not maxed out to 1. Yeah? So an alternative way of characterizing mechanisms that have single plateau is that it can never be the case that a shift of probability mass from 2 extreme points inside is feasible. Yeah? So whenever this is feasible, then the mechanism is not in single plateau form. This is an equivalent characterization. So under which condition is our optimal mechanism in the single plateau form? So we need a regularity assumption for that. So first remember that we're in a case of positive correlation. So this means that this ratio is strictly decreasing. Now the regularity assumption is that it's not only strictly decreasing, but also convex. Yeah? This regularity assumption is not entirely new. There's a stronger assumption in the literature by Jewett. And this new regularity assumption follows by Jewett's assumption, but not the other way around. So this is very good news because Jewett's assumption is already fulfilled by many distributions that we usually work with. And then under the regularity assumption we can show that in the optimal mechanism any allocation schedule is in single plateau form. Yeah? So the second property we are going to show is that these allocation schedules in single plateau form are ordered in a specific way. And to express this, I define the following partial order on the sets of allocation schedules for two valuations, V double prime and V prime. One allocation schedule is higher in this order than the other if the differences seen as a function of C is single crossing from below. Yeah? And then we have that a mechanism is monotone if it is monotone with respect to this partial order. And finally, we can prove that the optimal mechanism has, under positive correlation, has single plateaus, and these plateaus are ordered in this plateau monotonicity. There's one interesting thing here. Plateau monotonicity does not mean interim monotonicity. This means that there are examples where we have this optimal mechanism that gives a lower type the good with higher probability than to a higher type. This is in the paper. Okay, to wrap it up. So what have we shown? We have shown that basically for any type, for any valuation type, the allocation schedule is in this single plateau form, and that these single plateau forms are ordered, so you can really think about they are shifted to the right in some sense, so you can think about this mechanism as a staircase. Yeah? If you go to the extension where we allow for the cost to be distributed on an interval, then we get that the single plateau-ness translates into an interval allocation. So this is what we have seen in the example before. Whenever the cost realizations after which, so first the mechanism is deterministic, it is either allocates with probability 1 or 0, and then the cost realizations after which the mechanism allocates form an interval. Yeah, this is what we have seen, and then the monotonicity translates into interval monotonicity, which is quite easy. It just means that the lower and upper bounds of these intervals are increasing in the report. Okay, that's it. Thank you.